For this one, you're going to use the relationship. Okay, basically, if you use it, and then you can simplify the term directly. For this question, it depends on whether you can recognize this is actually equals to tangent theta. Okay, so if you have this one, then you will know it is actually equals to tangent square theta. So for this one, actually you have to group the term together, okay, by adding the bracket. So once you consider this one, and now you should know it, that is equals to 1, and you have 0 at the end. So for this one, it is a little bit tricky. You should know it according to, okay, this one. Then you can just move the term to another side so you know it, like this. So you can change it to sine square theta over sine theta, which gives you sine theta at the end. So for this one, this time you just break it into two parts. Okay, once you break it into two parts, you can see this is what you have, and basically you have tangent square theta minus 1. Okay, for this one, this time you take out the common factor, which is cosine square theta. So you will have this with you. So by using the identity, you know that you only have cosine square theta at the end. Okay, for this question, you have two methods. Okay, the first one, you draw the right triangle, sorry. And this is theta, and this is the opposite side, this is the hypotenuse. So at the end, you know that this side actually equals to 17 squared minus 8 squared. This is because of the Pythagoras theorem. That is why this one you can find out this is 15. So you know cosine theta equals to 15 over 17. For tangent theta, you will have 8 over 15. Okay, this is method 1. And for method 2, okay, you just use the identity. So you know that this is sine theta, okay, and you know that sine square theta plus cosine square theta equals to 1. So you have 8 over 17 square plus this cosine square theta equals to 1. So you have this one, okay, and this one. That is why you know it. Cosine square theta equals to 17, and this one, 9 here, times 17, and here will be 25. So you can check it will be cosine square theta equals to this. Okay, so you know cosine theta equals to 15 over 17. Okay, and as you know it will be the tangent theta actually equals to sine theta over cosine theta. That is why you will have 8 over 17 over 15 over 17. So when you multiply 17 for both numerator and denominator, you have 8 over 15 at the end. This is method 2. So for this one, now you are given tangent theta equals to 12 over 5. So basically, you can just set up the equation like this, okay? And you draw it, 12 and 5 here. Okay, and then you can actually find it for this one. Will be equals to 12 squared plus 5 squared equals to 13. In this question, you cannot use another method. That means you cannot use the identity only to find it. That is why for cosine theta, in this case, it is equals to 5 over 12 squared plus 5 squared, which will give you 5 over 13, like this. And then you're going to find out sine theta as well. So accordingly, I guess you can see it, it is obviously equals to 12 over 13. So 2 cosine theta minus 3 sine theta actually equals to 2 times 5 over 13 minus 3 times 12 minus 13, which will give you, okay, 26 over 13 with negative here. So you have negative 2 at the end. So this time I prefer method 1, which means you just draw the triangle like this. So you have root 3 here and 3 here. This time you know it will be you have 3 square minus 3, okay, or root 3 over square, so which give you root 6. Okay, that is why sine theta actually equals to, like this one, okay, over 3, which gives you at the end root 6 over 3. And for 1 over tangent theta, actually that is equals to 1 over, and here root 6 over root 3, so which gives you 1 over root 2. Okay, that's it. For this one, you are going to change it, so you have 1 over cosine square, so you can just change it like this. Okay, and then you can see that for the first part, actually, you change it back to sine square theta over cosine square theta. So once you change it, you can see it is very obvious. You have 1 minus sine square theta over cosine square theta. So you have this one, and when you do the simplification, you have 1 at the end. For this one, take out the common factor, so you have 4 and 1 minus cosine square theta. And then you have 2 and this one. So you know this is 2 sine theta at the end. Okay, for this one, again, use the identity so you know it. You have to combine them, okay, and then change the denominator, and then you change the numerator like this. So you have 2 over 1 minus sine square theta. So you can also change it back to cosine square theta like this. For this one, okay, you are going to use this very often. So you can multiply by 1 over cosine square theta like this, and then you times it. So you have cosine square theta plus this one. This is actually equals to sine square theta. So you have cosine square theta plus sine square theta, which means you have 1 over 1 at the end. For this one, you are going to do the simplification like this. You change tangent theta back to the definition, so you have sine theta over cosine theta. So as you can see at the end, you have 1 over cosine theta. Okay, and now you know that for B, you're going to find this. This one actually equals to 1 over cosine theta. Therefore, the value actually equals to 1 over cosine theta, and it is equals to 1 over 8 over 9. So you have 9 over 8.